Okay, so continuing from the previous lesson with graphing, we graphed with slope-intercept, we graphed with x and y intercepts, and now we're going to learn how to use the point-slope form to get a graph. So in point-slope form, first thing you want to do is identify the point that is used in the equation. Okay? You want to identify the point. So what helps is rewriting it. So if I go y minus y1 equals m times x minus x1, we want to pull out the point, the x1, y1. Okay, that's our point that we use to write the equation. So if we're using the formula here and comparing it with the equation that we have, what would our x1 number be? I had somebody say 3. Okay, we have a negative 3. So we have a positive 3 and a negative 3, sticking with the 3. So let's look at our formula so that we can determine whether it should be the positive or the negative. In the formula, there is a minus. In our equation, there is a plus. So what kind of a number does x have to be? So when I do minus that number, it makes it a plus. It has to be a negative. Okay? So that's why this is helpful to write down this formula and then compare it, because if the signs are different, then the number has to be a negative number. Okay? So that'll be our negative 3. And what about the y? Okay, so 2. Okay, so the minus is part of our formula. So then the y is just the positive 2. So negative 3, positive 2. So we identified the point. I should probably get my graph so I can plot it, because that was the next part of that. So I said identify the point and then plot it on the graph. So negative 3, 2. Negative 3, 1, 2. There's my point. Negative 3, 2. Next, going to identify the slope. Start at the point from part 1 and use the slope to plot another point. So our slope is m equals what? Negative 2/3. M is the slope. Here's the slope. So negative 2/3. So I've identified the slope. So number 2 says start at the point you just plotted. That's the negative 3, 2. So you're starting there. And then you do the same thing with the slope that you do in slope-intercept form. You start there. It's negative, so we're going to go down. So we go down 2 and over 3. Down 2 and over 3. Always to the right. So we went down right. Now we can go up left. Got to keep everything in a nice straight line. So then we can go up 2 and over 3. I think it's about right there. And then you draw your line through the points. Okay, not so bad. We just have to be careful with our positives and negatives when we identify the point. And then it's just like slope-intercept form. You use the slope from that point, get some more points, and then draw your line. Okay. Then you don't have to worry about any fractions if you rewrite it. Okay, so we want to write the equation of the line in slope-intercept form. First thing we want to do is to be able to identify some points that are on that line. Okay, so first identify 2 points from line. I have 2 marked, but there's a couple others that work. That one works, that one works, this one works. Okay, you only need 2 points. So identify what the 2 points are that you're going to use. So you identify the 2 points. Then you're going to find the slope. So you have to calculate the slope. So remember that's m equals y2 minus y1 over x2 minus x1. Okay, so you plug them in. So 4 minus 2, 3 minus 2, 2 over 1, which is 2. So we have a slope of 2. We want it in slope-intercept form. So we're going to plug in the slope and one of the points so we can find b. I do some abbreviations, so if you're not sure of my abbreviations, let me know. So PT for point, PT for point. I've been using that a lot. This is my shorthand for and. So pick a point. I chose the 2, 2. So that means the y is 2, the x is 2, and then my slope is 2. Everything just turned out to be 2. 2 equals 4 plus b minus the 4. B is negative 2. Write your final equation. So y equals 2x minus 2. I could then ask to write it in function notation. So how would I write it in function notation? Awesome. Okay. Because you are asked that on the test. Write things in function notation. So all I got to do, make sure it's in slope-intercept form first. That is the only format that you can rewrite into function notation. And all you do is change the y to f of x. But it must be in slope-intercept form. So that completes the graphing lesson. So there were just a couple of things that we needed to go over and review. All right, so let's work on some applications. So the one I wanted to start with was the one that you had on the homework. And then there's another one that I'll give you guys time to kind of read through, sort through, use some of the techniques that I talk about in this one to answer, and then I'll show you a solution and make sure we have all the parts, and I'll show you how I grade it. So cable television. In 1994, the average monthly cost for expanded basic cable television service was $21.62. In 2004, this cost had increased to $38.23. Write a linear equation that models the monthly cost as a function of the number of years since 1994. Predict the average monthly cost of expanded basic cable television service in 2010. So one good thing, this is the way I approach word problems. I was never good at them when I was in school. And so then I had to teach them. So that was a bit of a challenge to start with. So what I've done, and the way I recommend students to start, is first read through the whole problem. That kind of gives you an idea of what kinds of numbers are floating out there, what the problem's talking about, what the question is going to be asking. Then we go back and we try to start picking things out. So then I reread it, and as I reread the second time, I start underlining, circling, or rewriting information from the problem so that I can figure out how to set it up, okay? So we're just trying to understand the problem to start with. So let's see, in 1994, the average monthly cost for expanded basic cable, $21.62. So 1994, $21.62. 2004, $38.23. Okay, we want to write an equation. This expression is important. As a function of. As a function of is a very important phrase, especially when you're trying to translate from a word problem. We have monthly cost as a function of number of years. So I did some abbreviating. Okay, when I use that, that means number. Okay, so that's how I use it, to mean number. So this phrase, as a function of, whatever is in front, whatever wording that comes in front of that phrase is your y variable, always. Whatever comes after is the x, always. It's always y as a function of x. So that'll help you with defining your variables. So y is equal to the monthly cost. X is equal to the number of years. Okay, so then you can clearly define what your variables represent. Now, another part was right here. Since 1994. So I want how many years after 1994. So what would that mean? What number would represent 1994 then? If I'm wanting the years since 1994. Then yeah, it would be the 0. okay, because 1994 is 1994, so there are no years after, so then we want it to be 0. So this is going to be 0. Now what about 2004? How many years after 1994 is 2004? 10. So what this does is helps us set up an ordered pair. So I have x, y, x number of years, y is the monthly cost. So now take this information right here, and we're going to set up 2 ordered pairs. So that means 0, 2162, 10, 3823. Now it's exactly like the problem we just did the last graph before we switched over. 2 points, find the slope. You can start with point slope or slope intercept, either way, then rewrite it. So your final answer is in our function notation. So then you would keep going and finish, and we already went over this and looked at the answers from the homework. So let's go ahead and try another one. So I'm going to give you guys time to kind of sort through this one and try to get a complete solution, and then I'll show you a complete solution.